Okay, our next video is going to look at two different situations with bacteria and look at how their equations change based on the numbers that they start with. So I'm going to let you know that both my populations of bacteria, the rate of change of bacteria is directly proportional to the number of bacteria. And I have that information right here. Once I know that relationship is true, I know that I have a differential equation I can solve, and I can go through the steps like I did in the last video, but I already know it's going to be a bucket problem. It's going to be equal to B equals CE to the KT. This one is also going to be B equals CE to the KT. But I'm going to let you know that at time 0, this set of bacteria had an antibiotic put into it. Okay? That's not going to change what we call the general equation for each one. That means an equation with no numbers in it. But it will change our specific solution as time goes by. As a matter of fact, for my first collection of bacteria over here, I'm going to tell you that when time was 0, the number of bacteria was equal to 1 million. Now let's go 1,000. We'll make it small. And I'm going to let you know that on my other one over here, that when time was equal to 0, bacteria was equal to 1,000. They both had the same starting situation. Now, this one at time after 4 hours, the number of bacteria was equal to 2,400. And for my next one right here, I wrote that in the wrong color, hold on. So my second one, at t equals 0, B was equal to 600. So what's happening? The one that had the antibiotic in it, the population is decreasing. The one that did not, the population is increasing. Let's see how that affects the equations. So step 1 in solving a specific solution is first to insert the initial condition into each so you can find the value. So for this one, it's 1,000 equals CE to the K times 0. And this one is 1,000 equals CE to the K times 0. Now K times 0 is 1, so that part's gone. Sorry, K times 0 is 0, E to the 0 is 1. That happens on both of them, and I've instantly found C for each problem. Now I'll use the next point and substitute it in to find the value for K, which tells me the rate. So on this one, it's going to be 2,400. Ooh, that's a terrible color. Let's fix that. 2,400. Wait a minute. Who wrote that down as 0? Silly person. They meant at time 10. So I changed the problem a little bit. You'll live. Now it looks like 110. Oh, jeez. Oh, now I messed it all up. Okay, so we're filling the next point. 2,400 equals, I now know C. C is 1,000, which is almost always the initial condition. E to the K times 10. And this one is 600 equals 1,000. E to the K times 10. Okay, so now on each side I'm going to try to solve for K. So the first thing I'm going to do on each side is I'll do this side first. I'm going to divide by 1,000. Hey, that's fine. I'm going to do the same thing on the other side. And I'm going to get, I'll do 24, oh, I got my new calculator here. Okay, 2,400 divided by 1,000 equals, hey, that equals 12 over 5, or 2.4. Nope, that says 24. 2.4 equals E. Now let's just change that order and make it say 10K. And this one is 600 divided by 1,000. That's equal to 0.6. 0.6 equals 10k. Who wrote 10k? Equals e to the 10k. Now, to get rid of the e, I'm going to ln both sides of each equation. ln, 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 ln. That cancels there. And we get ln of 2.4 equals 10k. So that means k is equal to ln of 2.4 over 10. On this side, I'll do the same thing. ln of 0.6 equals 10k. Divide both sides by 10. And get a ln of 0.6. All of that over 10 is equal to k. And now I'll do that in the calculator. A lot of times you don't even ask you to solve it out, but I'm going to do this. ln of 2.4, enter, divided by 10, and I got k is equal to 0.0875. And I'll do the other side. ln of 0.6, enter, divided by 10, and I got k is equal to negative point. So I got k equal to negative 0.0510. So my equations would be the following for this function right here. It's going to be that b equals 1000 e to the 0.0875t. That's the exponential equation for that one. For this one, it's b equals 1000 times e to the negative 0.510. 0510. 0510t. Now you'll notice that the first equation has a positive exponent, and that's why that function increases, and the second equation has a negative exponent, and that's why that function decreases. Up top, those are known as general solutions. This is known as a specific solution. Okay, folks, there's 2 videos for now, and we'll work on this more tomorrow. Take care.